Hi friends, welcome to Time to Learn TNPSC. நீங்கள் பார்க்க போகிற சாப்டர்னா மேட்டர் அரவுண்ட் அஸ். ஆல்ரெடி நம்ம 6th ஸ்டாண்டர்ட் பார்த்துருக்கோம். நான் கொடுக்குற எல்லா சாப்டருமே ஜஸ்ட் நோட்ஸ் தான், நீங்கள் பார்த்தாலே புரியும். நான் கீழே டிஸ்கிரிப்ஷனில் லிங்க் கொடுக்குறேன். Atoms. The graphite refill used in pencil is made up of element called carbon. We can break the graphite into smaller and smaller pieces. In fact, if we have an even finer knife, we can break it even smaller. If keep cutting the minuscule graphite into smaller and smaller particle, we will reach a point where we reach smallest constituent of graphite carbon atom. If we break that carbon atom apart, then it will no longer exhibit the properties of carbon. The smallest unit of an element that exhibits the properties of the element is called as atom. All the matter is composed of tiny particles called atom. Water, rice, in short, everything we see around is made up of atoms. கீழே பிக்சர் கொடுத்துருவாங்க. An atom is the basic unit of a matter. Even with the best of optical microscope, we cannot see atoms. However, there are advanced instruments that helps us to image the atoms on the surface of a material. For example, the following figure shows an image of the surface of silicon. Do you know the most abundant type of atom in the universe is the hydrogen atom? Nearly 74% of the atoms in the universe are hydrogen atoms. However, on Earth, the three most abundant atoms are iron, oxygen, and silicon. Molecules. When an atom combines with another atom or atoms and forms a compound, it is called as a molecule. A molecule is made up of two or more atoms chemically combined. Oxygen gas in the air that we breathe is made up of two oxygen atoms chemically combined. Ozone is a substance that is made up of three oxygen atoms chemically combined. An atom of oxygen and two atoms of hydrogen combine to form a molecule of water H2O. O3. Ozone. Formation of photomolecules. Molecules also exhibit properties of matter and have individual existence. A molecule can be formed by the same or different kind of atoms. Hydrogen plus oxygen equal to water. Molecules can be classified as follows. A molecule which contains only one atom is called monatomic molecule, inert gases. A molecule which contains two atoms is called diatomic molecule, oxygen, nitric oxide, and hydrogen, etc. A molecule contains three atoms is called a triatomic molecule, ozone, sulphur dioxide, carbon dioxide, etc. A molecule containing more than three atoms are known as polyatomic molecule, phosphate and sulphur, etc. Molecules of elements. A molecule of an element consists of a fixed number of one types of atoms chemically combined. The table below show gases that are made up of two atoms of the same type of element. Molecule chlorine gas, oxygen gas and nitrogen gas கொடுத்துருக்காங்க. மாலிகுல் டயக்ராம் வந்து எப்படி chlorine வந்து Cl ரெப்ரசன்ட் பண்ணாங்க, oxygen O, nitrogen N. Molecule model, ball and stick. Chlorine molecule, oxygen molecule and nitrogen molecule. For example, let us look at the model of a water molecule below. Each molecule of water consists of one oxygen atom and two hydrogen atoms. This ratio of oxygen and hydrogen atoms remains fixed whether water is in liquid, solid or gaseous state. This principle applies to the molecules of all compounds. Do you know bismuth in diarrhea medicine? Bismuth is an element that occurs naturally. It is combined with other elements to make medicine for treating diarrhea. Molecules of some compounds. Molecule carbon dioxide, ammonia, hydrogen chloride. Molecular model ball and stick கொடுத்துருக்காங்க. Configuration of matter. Atom. Smallest particle of an element. Molecule. Molecules are made up of atoms. Element. Chemically simplest substance cannot be broken down. Compound. Two or more elements are chemically bonded together. an element hydrogen, a compound water. Chemical formula. Tell the number of atoms element in a compound. CH3COOH. Chemical symbol. Short representing of chemical element. Hydrogen atom, carbon atom and benzene C6H6. Classification of matter. Matter is classified into two broad categories, namely pure substance and mixture. Pure substances are further divided into categories as elements and compounds. Elements. Matter in its simplest form is called an element. We are using many elements in our daily life. The common salt is consisting of elements of sodium and chlorine. Water consists of hydrogen and oxygen. Magnesium and phosphorus used for making crackers. Sulphur is used as a manure in agriculture. Gallium is used for making mobile phones and silicon is used for making computer chips. There are 180 known elements till date. 94 of these elements occur naturally, while 24 elements have been created artificially in the laboratory. Classification of elements. We can classify the elements broadly into metal, nonmetals and metalloids based upon their chemical properties. Do you know that Robert Boyle is the first scientist who used the term element, a early proponent of the elemental nature of matter and the nature of vacuum. He was known best for Boyle's law. Metals. We have tools, utensils and jewelry made from silver, copper, iron, gold, aluminium using pressure like hammering or rolling. We can deform these materials into various shapes. Such elements that are malleable. A material may be flattened into thin sheets or various shapes is called as a metals. Metals are generally hard and shiny elements. Sodium is one of the expectation as it's soft. All metals except mercury are solids at room temperature. Mercury is the only metal that is liquid at room temperature. Metals are malleable, can be bent or beaten into sheets. They can be drawn into wires. They are good conductors of heat and electricity. Copper, lead, tin, nickel, iron, zinc, gold, magnesium and calcium are examples of metals. Copper, lead, iron, nickel, steel and zinc. Nonmetals. Nonmetals are generally dull and soft. However, diamond is shiny and also the hardest natural substance on earth. Nonmetals can be gases, solids, liquids. Nonmetals such as oxygen, hydrogen and chlorine are gases at room temperature. No metals such as carbon, iodine, sulphur and phosphorus are solids at room temperature. Bromine is the only nonmetal that is liquid room temperature. Nonmetals are poor conductors of heat and electricity. However, graphite, a form of a nonmetal carbon, is a good conductor of electricity. Carbon, phosphorus and sulphur. The difference between metals and nonmetals. Metals are lustrous, they have a shiny surface. Nonmetals are non-lustrous, they have non-shiny surface. Metals are generally hard, nonmetals are generally soft. Most metals are bendable, nonmetals are non-bendable. Most metals can be bent, beaten into sheets and they can drawn into wires. Nonmetals are non-ductile. Most metals are good conductors of electricity. Nonmetals are bad conductors of electricity. Most metals are good conductors of heat. Nonmetals are bad conductors of heat. Most metals are making ring sound when struck. Hence they are used to make objects like bells. Nonmetals does not make any sound when they struck. Metalloids. Metalloids exhibit the properties of both nonmetals and metals. Silicon, arsenic, antimony and boron are some examples of metalloids. Boron indicated as B, silicon Si, germanium Ge, arsenic As, antimony Sp, tellurium Te. Compounds. A compound is a pure substance that is formed when the atoms of two or more elements combine chemically in definite proportions. Compounds exhibit properties entirely different from the properties of their constituent elements. For example, the atoms of the element hydrogen and oxygen combine chemically in a fixed ratio to form the compound water. However, water does not have the exact same properties such as hydrogen and oxygen. For example, at room temperature, water exists as liquid while hydrogen and oxygen exist as gases. Also, oxygen supports fire, whereas water is used as a fire extinguisher. Similarly, common salt, sodium chloride is a compound made up of elements sodium and chlorine. It is used in our food, whereas sodium and chlorine are poison or both unsafe for consumption. Sodium is a highly reactive solid at room temperature. It burns vigorously when in contact with water. Plus chlorine is a yellowish green color poison gas at room, equal to sodium chloride, used for cooking. Elements in the compound: table salt, sodium and chlorine; sugar, carbon, hydrogen and oxygen; chalk, calcium, carbon and oxygen. Properties of compound. A compound is formed only when the constituent elements combine in a fixed proportion. The properties of a compound are different from those of its constituent elements. A compound cannot be broken down by physical methods. This is because a compound is made up of different elements that are chemically combined. Sodium chloride cannot be separated by physical methods such as filtration. A compound can be separated into its constituent elements by chemical methods only. Difference between an element and a compound. Element. An element is a simple substance. Compounds. A compound is a chemical substance formed with a combination of two or more elements. Elements combine into form compounds. Compounds can be split into elements. Atoms are the fundamental particles of an element. Molecules are the fundamental particles of a compound. Symbol of an element. Symbol is an abbreviation or short representation of a chemical element. There is a unique symbol for each element. It represents one atom of the element. The symbol is usually derived from the name of the element, which is either in English or Latin. These symbols are allocated by the International Union of Pure and Applied Chemistry, IUPAC. Dalton was the first scientist to use the symbol for elements in a very specific sense. When he used a symbol for an element, he also meant a defined quantity of that element, that is, one atom of that element. Berzelius suggested that the symbols of elements can be made from one or two letters of the name of the element. Symbols for some elements as proposed by Dalton: hydrogen, phosphorus, copper, gold, carbon, sulphur, lead, platinum, oxygen, iron, silver and mercury. The following rules are followed while assigning symbol to an element. Chemical symbols usually consist of one or two letters. The symbol of most elements correspondent to the first letter, which is capitalized, of their English name. For example, the symbol for oxygen is O and that for hydrogen is OH. When there is more than one element that begins with the same letter, the symbols take two letters. The first letter is capitalized while the second letter has a lowercase. For example, the names of both hydrogen and helium begins with H. So, hydrogen is represented by the symbol H and helium by He. Similarly, the symbol for carbon is Ca, while the symbol for calcium, chlorine and chromium are Ca, Cl and Cr respectively. Element represented by single letter symbol. Element and their symbol: hydrogen H, fluorine F, oxygen O, carbon C, phosphorus P, sulphur S, potassium K, uranium U. Elements represented by symbols of two letters. Element and symbol: aluminium Al, argon Ar, arsenic As, barium Ba, nickel Na, bromine Br, chromium Cr, cobalt Co, helium Ha, magnesium Mg, calcium Ca and chlorine Cl. The symbol for some elements are derived from their Latin names. For example, the symbol for gold is Au after its Latin name aurum. Similarly, the symbol for copper is Cu after its Latin name cuprum. Elements and their Latin name: copper is Cu due to cuprum, lead plumbum Pb, potassium kalium K, iron ferrum Fe, mercury hydrogen Hd, sodium natrium Na. Do you know In the beginning, the names of elements were derived from the name of the place where they were found for the first time. For example, the name copper was taken from the cypress. Some names were taken from specific colors. For example, gold was taken from the English word meaning yellow. Nowadays, IUPAC approves names of elements. Many of the symbols are the first one of two letters of the element's name in English. The first letter of a symbol is always written as a capital letter, uppercase, and the second letter as a small letter, lowercase. Chemical formula. Often we hear that water is H2O. This is the chemical formula for water molecule. This means that each molecule of water has two hydrogen atoms combined with one oxygen atom. A chemical formula is a symbolic representation of one molecule of an element or a compound. It provides information about the elements present in the molecule and the number of atoms of each element. Can you guess the types of atoms and number of each of the atom in NaCl, which is a chemical formula for cooking salt? The chemical formula tells us the type of atoms and the number of each type of atom in one molecule of substance. Here are some examples of chemical formula. Sodium chloride NaCl, 1 atom of sodium and 1 atom of chlorine. Ammonia NH3, 1 atom of nitrogen and 3 atoms of hydrogen. Glucose C6H12O6, 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. Water H2O. The small number beside the H symbol is called subscript. It tells us the number of atoms that element present in the molecule. Hence there are 2 hydrogen atoms in water molecule. When there is no number of besides O symbol, it means there is only one atom of that element present in the molecule. Hence there is one oxygen atom in an water molecule. Common compounds and their chemical formula. H2O water, C6H12O6 glucose, NaCl sodium chloride, C2H6O ethanol, NH3 ammonia, H2SO4 sulphuric acid, CH4 methane, C12H22O11 sucrose. Atomicity. In chemistry we usually understand atomicity to imply the total number of atoms present in one molecule of an element, compound or a substance. Let me see how to calculate the atomicity of elements. For example, oxygen exists as a diatomic molecule, which means that a molecule of oxygen contains 2 atoms. Hence, its atomicity is to O plus O equal to O2. Similarly, a phosphorus P4 molecule contains 4 atoms. A sulphur S8 molecule contains 8 sulphur atoms. Hence, their atomicity is 4 and 8 respectively. For a molecule containing more than one types of atoms, simply count the number of each atom and that would be its atomicity. For example, a molecule of sulphuric acid H2SO4 consists of 2 hydrogen atoms, 1 sulphur atom and 4 oxygen atoms. Hence, its atomicity is 2 plus 1 plus 4 equal to 7. One molecule of water H2O contains 2 atoms of hydrogen and 1 atom of oxygen. The atomicity of water is 3. Atomicity of some elements. Element atomicity, elements atomicity. H2, He1, Li1, N2, O2, F2, Ne1, Na1, P4, S8. Elements in human body. Nearly 99% of the mass of our human body consists of just 6 chemical elements: oxygen, carbon, hydrogen, nitrogen, calcium and phosphorus. Another 5 elements make up most of the least percentage point: potassium, sulphur, sodium, chlorine and magnesium. Elements in air. Air is a mixture of gases. The molecules of 2 different elements, nitrogen and oxygen, make up 99% of the air. The rest includes small amount of argon and carbon dioxide. Other gases such as neon, helium and methane are present in trace amounts. Oxygen is a life-giving element in the air. Effect of temperature on solid, liquid and gas. What happens to matter during heating? The following are models of particles in solid during heating. These models can be modified to represent heating in solids, liquid and gas. When solid is heated, the particles gain energy and vibrate vigorously. The particles move slightly further apart from one another. This causes the volume of matter to increase. This process is called expansion. How it happens? The matter begins to expand when heated. The volume increases due to greater distance between the particles, but the size of the particle remains the same size. During heating or expansion, the mass of matter does not change. This is explained the following way. During heating, the distance between the particles of the ion logs change. Mass is conserved when matter expands. Although the volume of the matter changes, the size and number of the particles of matter do not change. However, during heating, the mass of your matter is conserved. For example, in an iron log, the distance between the iron particles increases when they gain enough heat. However, the number of iron particles does not change. Hence, the mass of the iron log is conserved. The melting of ice is an example of a change in the states of matter. The change in the states of your matter occurs during melting, boiling, and freezing and condensation. When the particles possess enough energy, they overcome the strong forces of attraction between one another. The particles break free from one another and move randomly. For example, when solid ice is heated to 00 degrees Celsius, it melts to 100 degrees Celsius. It melts to become liquid water. The same way, liquid water is heated to 1000 degrees Celsius, it boils to become steam. Solid. When solid is heated, the particles gain energy and vibrates more vigorously. Liquid. Melting occurs when the melting point is reached. The solid changes to its liquid state. When a liquid is heated, the particles gain energy and vibrate more vigorously. Gas. Boiling occurs when the boiling point is reached. The liquid changes to its gaseous state. Points to remember. An atom is the smallest particle of an element. Elements are the simplest form of pure substance. Molecules of an element consist of a fixed number of one type of atom. Molecules of a compound consist of a fixed number of different types of atoms. The molecules of the different element, nitrogen and oxygen, make up 99% of the atom. The particles nature of matter can be used to explain heating effect of solid, liquid and gas. The mass of the matter remains same during expansion. A molecule is made up of two or more atoms chemically combined. We can represent a molecule using the formula. Thank you. Please share, subscribe and comment. Thank you.